Hi, I don't know what I'm doing, and this is a flamethrower that shoots hand sanitizer, and it's made from a yardstick, some pens, a couple of bottles, and a tape dispenser, as well as a handful of 3D printed parts. Because my goal on this channel is to use as many common office and household products as possible in each of my builds, I faced 5 engineering challenges before I could get my flamethrower working. 1. Would hand sanitizer even ignite when shot in a stream? 2. How do I make an airtight actuating valve out of 3D printed parts and some office supplies? 3. How do I store the pressure that this thing is going to need to fire? No pun intended. 4. I'm going to need a solution to lock the butane lighter into the on position. And finally, 5. How am I going to make a fully functional assembly out of nothing but office supplies? The first question I had was, would hand sanitizer even work for this? I mean, it's pretty flammable while it's just sitting here. But my question is, will it maintain ignition as it travels through the air? That's what we need to find out. So I grabbed a syringe and I tested it out. Like the gas in your car, it's not the actual fluid that combusts, it's the vapors that rise off of it. Now, hand sanitizer does have alcohol in it, but sitting at room temperature in hand sanitizer, we're not getting any vapors off of it. I think the best solution is to heat this and see if we get those vapors to off gas, making them more readily available to ignite. Whoa, look at that. That's what we're looking for. Now that we have the hand sanitizer question figured out, it's time to move on to engineering the valve. As much as I'd love to stick with strictly office supplies to make this valve, there's just not enough efficiency in trying to make airtight connections between parts that were never meant to fit together. So I'm gonna need custom parts for this one. Okay, I'm gonna show you something if you promise not to laugh. But this was the first idea I had for this thing. And I thought that I could just 3D print a huge chunk of plastic and it would be airtight, because I don't know what I'm doing. Clearly that's not the case. So I'm gonna switch to printing individual components, working to make each of those airtight, and then gluing them together at the end to see if we get a better result. I went through quite a few different valve prototypes, trying to model them after real-world existing valves. But the first bit of progress I actually made was when I realized the 3D printed components I was putting out were not actually airtight. So I began epoxying everything, and that seemed to make a big difference. The biggest challenge I faced with this valve was getting it to actuate without leaking. I mean, what good is a valve that can't maintain pressure when it's in use? I solved this by creating a chamber at the bottom of the valve that tightly fits the eraser from a mechanical pencil and is held in place by another small disc that's glued on to close the chamber. This allows the paperclip that mechanically actuates the valve to move through the eraser while the valve maintains air pressure. A drop of oil helps to both seal and lubricate this fitting. Next was the issue of holding back the air pressure I needed to expel the sanitizer from the flamethrower. This can of air duster puts out between 50 and 70 psi. That's a lot of air pressure for a 3D printed valve to have to hold. To solve this, I'm going to need tighter tolerances than I can get out of my 3D printer, and the machined end of this Bic pen is perfect for this. If I can apply enough pressure to the end of this Bic pen with a small piece of rubber band, I think I can create a strong enough seal. So the super scientific way I've been testing my valves is to just blow into them and see if I get air. So let's test this one. This valve design works great. I get no air leakage out of it and I can operate it without losing pressure. So with the valve design out of the way, it's time to figure out how we're going to store the pressure from the canned air. Now, in order to store pressure in whatever canister I decide to use, the first thing I need is a one-way valve. Fortunately, I've developed one of these in the past using nothing but pen parts. Typically, it uses a rubber band as the rubber seal inside, but I don't think that's going to be strong enough for our purposes on this. So instead, I found this lovely, sturdy rubber that smells just like cancer. We're going to use that instead. As I was pressurizing this bottle, I noticed the amount of deformation I was getting in the plastic from the pressure. And it occurred to me that I'm probably losing a lot of efficiency because some of the pressure that I want shooting sanitizer out of the nozzle is being used to deform the plastic of the bottle. I think there's a more efficient way to do this. As much as I enjoy the buildup of microplastics in my brain and my balls, I switched to these aluminum cans a while back just because they don't expand when pressurized. Before I can even test this out, I have to figure out how to 3D print threads that'll fit on this bottle. So I designed this lid to accommodate the shape of the valve so there's more surface area to glue together. It's got a cancer rubber seal on the inside, and I'm going to pressurize it and hopefully it holds pressure, so let's find out. Oh, perfect. Okay, I'm going to pressurize this and see how well this thing works. Wow, I don't hear a single leak. I've sprinkled some salt on this table so you can see what kind of pressure release we're getting from this. Let's try it. That's pretty good. This is going to hold the fuel for the flamethrower, and it's going to be upside down. Now the pressure is going to come in through the bottom here, but the hand sanitizer is going to come out from the side. Now that pressure is going to look for the easiest route, which is straight from the bottom to the side, but we don't want it to do that. We want it to have to go to the top of this bottle, which is the bottom, and push down on the hand sanitizer so it's forced out the nozzle. So this should thread just right into here like this, and then this will attach to our valve here, and we should get down pressure on the sanitizer so it shoots out the nozzle in the front. The idea to print all of these components individually has made a huge difference in their quality and function. I've been able to get epoxy on all the parts to keep them airtight, and now I'm really excited to get the rest of this thing built. With the first 3 engineering challenges out of the way, I now need a solution to lock this lighter in the on position. When I pull this lever back, it clicks the lighter on, but then canters over further to lock the lighter in the on position using the spring-loaded trigger on the lighter. Only until you flick it back manually does it shut off. This works great. So now I just need to find all the right office supplies to bring all these parts together. No sooner had I finished my flamethrower when I walked out in my garage, and this guy started harassing me. He was all like,
"Hey pal."
And I was like, "What?" But then he was like,
"I've got a problem with you."
And I was like, "Who, me?" But then he was like,
"Yeah, you."
And I was like, "Oh yeah? Well, I got something for wise guys like yourself. Check this out." And then he was all,
"Please don't kill me." I spent so much time torching that knucklehead that my coffee went cold.
Oh.
It's okay. I can heat it up again. This was a super fun build. I learned a ton about 3D printing and its capabilities and limitations. If you guys have recommendations for 3D printers, filaments, or ways that I can improve my 3D printing, I'd love to hear about it in the comments. I'd also love to hear what you think I should build next. In the meantime, I'm gonna be looking for more practical uses for my flamethrower, like reheating this cup of coffee. That's really good. If you like this video, please like and subscribe, and we'll see you next time.